Okay, we're in section 17 of the notes, and this is a section that's going to cover the material necessary to complete for exercise number 17. So Wells's text basically has exercises and material designed to get you ready to do those exercises. All right, so again, we're in section 17. This is Ron Bannon's draft version of Webster Wells' Advanced Course in Algebra. All right, there's contents. I'll scroll through that. Examples, which I'll go through, and exercises that you need to work on your own, all right? And again, this stuff, at least the PDFs, are being distributed to the Prison Mathematics Project participants. At some point in the future, I will publish this. If you need to reach out to me for whatever reason, my email address is Bannon, that's B as in boy, ANNON.US. Now, clearly, you're watching these videos on YouTube. You should realize that there's a standard way that I'm labeling these videos, and you could search for various section numbers. They're not up yet, but what I mean, they're not all up yet. I'm at 17 now. Eventually, I'll get to 139. But I'll be honest with you, the further they go on, the more difficult they're going to become. Right now, these initial ones really aren't bad. All right. So the claim about this one over here is that at least students have access to the PDF document. They can read through this, and that's fine. You should read through that. All right. What's clear about this, though, is I want to get to the examples, and the examples are going to be this sum and difference of perfect cubes. So this is sum of perfect cubes, and this is a difference of perfect cubes. All right. So these are two patterns that you would need to know about to do these particular problems over here. Now, reading these things over here, what I'm going to say is there's a really good chance that it has something to do with these patterns over here. So looking at this one over here, I'm going to say this looks like a difference of perfect cubes. All right, let's write it down. I'm going to say x squared. And the reason that x squared cubed is x6, which is going to be 3, because 3 cubed is 27. You're going to get y cubed, because y cubed cubed is y9, and z. Well, let's write this down now. So I'm using this pattern. And what are you going to get? Let's write this down. X squared minus 3y cubed z. Now the second guy's a trinomial. I'm going to square the x squared. That's x4. And then it's going to be plus the product of x squared and 3y cubed z. So that's plus 3 x squared y cubed z. Yeah, I like to keep the alphabetical order with numbers up front. And last but not least is the square of the last term, which 3y cubed z, which would be plus 9y6 z squared. Now mistakes happen. That's why we give you a key. I'm looking at the key. You want to make sure the key is what we say it is, which is x squared minus 3y cubed z. I got the first factor right. Let's see if we got the second factor correct. I got x4, 3x squared, y cubed, z. Yeah, looks pretty good. Plus 9y6, z cubed. Again, I do want to point this out. I know I said a lot to you. My chicken scratch sometimes hard to read, but the typeset version is very easy to read, and that's the whole point of it. We want to get to the point where you're typesetting these things. All right, let's look at this one over here. And again, my assumption is it's something to do with the patterns, and let's write this down. So something to do with cubes. And let's write this down. Looks like a squared, because a squared cubed is a6, and b squared. Let's write this down. What is it going to get? And again, we're using this pattern up here. All right? Let's write this down. So it's a squared plus b squared. And then what do you get? We'll have to square the a squared, so that's a4. And then it's minus the product of a squared and b squared, so that's a squared b squared, plus b squared squared, which is b4. Put a box in that. The box is saying I'm done. Look at this and make sure it's the same thing. And if it's not, there's probably an error somewhere. I'm not saying I don't make errors. What I'm saying is you really want to match things. If you're not matching things, there's probably a mistake somewhere. If you need to reach out to me, reach out to me. It looks pretty good. We got what we expected. Okay, let's go to the next one. And this one's a little more complicated, but not that much so. I'm going to write it down for you. It's a difference of perfect cubes. And I'll be careful. I'm going to use these square brackets over here. So it's going to be, let's see. And again, I'm pointing out that this is the second guy over here. It's this one. All right, so what's it going to be? Let's write this down. It's going to be x plus a minus x minus a. I'll simplify that later. Then this is going to be x plus a squared plus the product x plus a times x minus a plus the x minus a squared. Now, really, for some students say, I'm done. Now, I'm not saying you're not done, but I'd like to simplify. Just this first guy, let me point out what I mean by that. I'm going to do this right over here. Whoops, sorry about that. And let me just outline that again. I'm going to do this. And after I do that, I'm going to do this in here, right? One thing at a time. So let's do this first. X plus a minus x minus a is just 2a. That was simple. Now, the next guy is a little more complicated. Let me just go through it kind of carefully. It's x squared plus 2ax plus a squared. This guy's done. Let's do the next one. I'm going to do this now. What does this give me? X squared minus a squared plus, let's do this guy now. What's that going to give me? X squared minus 2ax plus a squared. All right? And it's a lot of work. I'm not saying it's not. So I see 2a, and now let me see if I can do what's inside this, grouping symbol. So I'm going to just look at the x squareds first. So you get x squared, and x squared. That's 3x squared, right? And then I'm looking at this 2ax, and I notice that disappears. Let's keep looking through this. A squared minus a squared, no a squares, but then there's a plus a squared. So I think I'm done. Look at the key. Make sure you can agree with it. What does it say? 2a times the quantity, 3x squared plus a squared. Worked out pretty nicely. All right, so this one over here, somebody will look at this and say, what do I do with this thing over here? And, it might be like impossible to do, but the fifth degree polynomial, and what they're saying is that, probably, and I'll go through this with you, probably there's going to be a factor over here that sort of looks like the other guys that we've been dealing with, right? So I'm going to say, they're fifth power. So let's just write that down for you. So I'm going to say it's a to the fifth, and this is going to be plus 2b to the fifth. So I'm looking at it, I'm thinking to myself, maybe I can start doing the factorization of this, but I'm not going to try to memorize anything. And what I'm going to recommend you do is maybe, make some, I'm not going to say an assumption, but you've seen patterns before. This is probably going to be a plus 2b times something that's rather complicated. All right, so my goal over here is that, let's see if it's true, all right? Now, certainly we have all kinds of theorems about this, but right now I'm going to say that we've seen that before. I'm going to say it divides in nicely, all right? Let's take a look, and let's write this down, and I'll write it down for you. A plus 2b is being divided into, and again, I'm trying to figure out this part over here. I don't know it. So it's going to be A5 plus 32 B5. I'm going to say A4. That would be A5 plus 2A4B. Well, a line there. Subtract. What do you get? Minus 2A4B plus 32B5. Let's keep going. Minus 2a cubed b. Let's keep going. Minus 2a4b minus 4a cubed b squared. I'm not beyond making a mistake, nor are you. Do the work. Now, again, I'm kind of squeezing it in here, but I'm going to do the subtraction now. What do you get? You would get 4a cubed b squared plus 32b5. I'm going to keep repeating. Now it's going to be plus, well, it's going to be 4. And you want an a cubed, so I need an a squared, right? You need a b squared, so put b squared down. Let's multiply. What do you get? 4a cubed b squared plus 8a squared b cubed. All right, let's keep going. Subtract. That disappears. What do you get? Minus 8a squared b cubed plus 32b5. Well, I got to do this now. Minus 8. Let's see, we need an a and a b cubed Now let's go to town on it. What do you get? Minus 8 a squared b cubed minus 16 a b4. Subtract. What do you get? Let's see. The minus 8 a squared b cubed disappears. What do you get? 16 a b4 plus 32 b5. I got to keep going, right? Now, what times a would give you 16 a b4? It would be plus 16 b4. What do you get over there? 16 a b4 plus 32 b5. And lo and behold, we get exactly what we expected, we get a 0. So I found out, right? And what I find out? I found out that other factor. Let me erase this business over here. We'll check the key later. And I found out that this over here isn't so bad. It's a4 minus 2a cubed b plus 4 a squared b squared. Yeah, I'm kind of jamming it in, aren't I? My eraser out. I'm going to erase this thing over here and keep jamming it in. And 4a squared minus 8ab cubed plus 16b4. Division is often helpful in doing these problems, by the way. Again, I want to make sure you understand we give you a key for a reason. We want you to look at it. And let's see. We got this. 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 Not bad. We got it. That's it. So what are you doing now? You're going to look at the exercises. All right. These are the exercises. All right. Exercise something you do on your own. And they're going to give you things that got those patterns. You know, sum and difference of perfect cubes, of course. These are sums and difference of perfect cubes. And over here, yeah, certainly a sum of perfect cubes. What's over here? More perfect cubes, it looks like. Yep, more perfect cubes. And over here, more perfect cubes. A lot of perfect cube problems, aren't there? Perfect cubes. Perfect cubes. Again, answers are being listed for you. Perfect cubes. Wow, a lot of perfect cubes, aren't there? Perfect cubes. And then they got this 5th degree thing over here. And again, a lot of people wonder, how would you do that? We're basically using those factor theorems that we have. And we certainly know it divides through by x plus y. Just give it a shot, right? Just give it a shot. And same thing over here. Divide through by a minus 1, right? Just give it a shot. Over here, divide through by a minus b. Over here, divide through by 1 plus x. You can do that. Over here, perfect cube problem. Not bad. You can still do that. Another perfect cube problem. You can still do that. Perfect cube, let me see. Yeah, perfect cube, you can do that. And let's see. And certainly I said I'm dividing, but you can do the perfect cube pattern. Over here, I would divide through by, it looks like 5th powers, right? So I'd say, 2, because 2 to the 5th is 32. So 2a minus b, divide through by that. And you could do that. You may do it for these things over here, really kind of simple pattern problems, all right? With the understanding he's going to teach them by doing it. Again, there's also related Sage code. That's about using a computer algebra system for those students wishing to go in that direction. Why do I like Sage? It's free. It's also used all over the world. It's a great product. That's the website. You click on that. If you have the PDF, it'll take you right to the website. You can download the application, or you can use the interactive web-based application. And this is something we introduced in the very early part of the course about how to do that, all right? And I actually went through that and I actually showed you how I used my machine to do it and how I use the interactive application to do it. But again, we would recommend, even if you're not looking at it saying, I don't know what I'm doing, you're just simply typing and looking, and there's something to do with what we presented before. Again, if you need to reach out to me, my email address, again, is Bannon. And you can do that, and we'll try to help you. Thanks for paying attention.